Hello friends, you are welcome to this lesson. I am Osas, the author of this channel, and in this lesson we're going to take differentiation to the advanced level. You will recall that in my last video we introduced the concept of differentiation and then solved numerous examples to illustrate the concept of differentiation. So in this lesson, we're going to take differentiation further. What does that mean? We're going to see the various techniques that are applied in differentiation. The first technique we're going to look at is chain rule. We look at quotient rule, and of course we also have the product rule. In this video, we will be paying attention to chain rule, and in my next videos, we're going to look at the quotient rule as well as the product rule. So let's get started. Chain rule is also called function of function. Chain rule has different conditions to be satisfied before it can be applied. The very first of those conditions is when the index of the function of function is greater than 2. When the index is greater than 2, then chain rule is the best technique for that problem. Number 2, when the function is enclosed in a root, that is, the function of function is in a square root format like what you are seeing here, then chain rule will be the best approach to it. If the argument of a trig ratio is also a function, then you can apply chain rule to solve that. These are the three conditions under which chain rule is applied. You're going to take note that no professional exam will ask you to state the conditions under which chain rule is applied. No, they don't do that. Rather, they will give you a problem. They expect you to look at the problem and know the best technique to apply, and as well as the procedure for that technique. And that brings us to the very first example we're considering today. Differentiate y equals to s squared plus 1, everything in bracket raised to power 4. Now, s squared plus 1 is a function on its own. Enclosing it in the bracket and raised to power 4 makes it a function of function. And the index we consider here is this 4. Since this index is greater than 2, it will not be advisable to expand this to power 4 before you start your differentiation. That will be too cumbersome. Chain rule makes the word simpler. What then is the procedure for chain rule? Just pick a new variable of your choice and equate it to the content of this bracket. For me, I like using u. I can now say let u be equals to s squared plus 1, which is the content of this bracket. Next, differentiate this with respect to x. That means get du by ds. And if you get du by ds, you're going to have 2s. You're actually differentiating this 10 by 10. These two will come down, subtract 1 from it, then you will have 2s. Just look at it now. Yes, your du by dx will be equals to 2s. Next, your y now will be equals to u raised to power 4. Remember, s squared plus 1 is your u. So everything now has been replaced by u. It will now be y equals to u raised to power 4. Differentiate this with respect to u. This 4 will come down, remove 1 from it. Then you will have the y by the u equals to 4u raised to power 3. You know we have illustrated this concept of differentiation in my last video. If you are not very comfortable with this differentiation, please do well to visit my last video and go through before you continue from here. I will be leaving the link to that video in the description. Then dy by dx, which of course we are asked to find, will be equals to dy by du, which we just found, times du by ds. It will be theoretically assumed that this du and this du, they cancel out. You are back to dy by dx. But rather than cancelling them, we rather multiply them. Our dy by dx now will be equals to 4u raised to power 3 times 2x. Fine. Recall that the dy by du is 4u raised to power 3 and the u by dx equals to 2x. Multiply these two together, you will have this as dy by dx equals to 8x u raised to power 3. How did we get this 8x u raised to power 3? 4 times 2 will give us 8. This s is this, and this u raised to power 3 is this. Now bring back the value of u back into this equation. If you bring u back, you will have 8x bracket s squared plus 1 raised to power 3. You remember that u was initially s squared plus 1. So if you differentiate the function we just had, you're going to get dy by ds equals to 8s into s squared plus 1, everything raised to power 3. That's the simple approach to chain rule. Let's take a further example. This example will illustrate the use of roots. Now differentiate y equals to square root of 2 plus 2 minus x raised to power 3. Again, pick a new variable u and equate it to the content of the square root. So I can now say let u be equals to 2 minus s cubed. Right? Differentiate this. If you differentiate a constant, it will go to 0 and leave us alone. Then differentiate this. This 3 will come down. Remove 1 from it, you have this 2. So du by dx will be equals to minus 3s squared. What next will you get? Bring back the value of u into this place. You will now have y equals to square root of u as shown below. Yes, y will be equals to square root of u. Now in this form, you cannot actually differentiate because you need the index before you can differentiate. So this can as well be written as u raised to power half. Root and index of half, they are exactly the same. Now in this form, you can differentiate. Dy by du will be this half will come down, then remove 1 from it. You will have half u raised to power minus 1 over 2. You are having minus 1 over 2 because this half is minus 1. So if you remove 1 from half, you will get minus half. That's how this negative half is coming in. Then dy by du will now be half times 1 all over u raised to power half. Why are we now having 1 all over u? Very simple. Because of this negative index. Remember, one of the laws of indices says that if you have a raised to power minus 1, it's the same thing as 1 all over a. So since I'm having u raised to power minus half, it will be 1 over u raised to power half. Then the dy by du now will be 1 over 2 root u. How? This 1 times this 1 will give us 1. This 2 is this. This u raised to power half, you go back to root. It will be like this. At this stage, having gotten your dy by du and your du by ds, you state the chain rule. Dy by ds equals to dy by du times du by ds. It will be theoretically assumed that this du and this du cancel out, but we normally don't cancel them. Please don't make the mistake of cancelling them. Rather, you multiply them. So bring back the value of dy by du and the value of du by ds and multiply them. This is what you will now have. Dy by ds will be equals to 1 all over 2 root u times minus 3s squared. If you multiply this and then bring back the value of u, you will finally have this as your final answer as dy by dx equals to minus 3x squared all over 2 root 2 minus s cubed, because this is the value of u. Fine, these are the two examples we want to take for this lesson. If you found this video to be very interesting, do us the honor and favor and then subscribe to this channel. Yes, smash the notification bell and destroy the subscription button so that whenever I upload a new video, you will be among the first to watch the video. I would like to receive your comments. Drop whatever comment you have in the comment section so that I can get your feedback. Thank you very much, friends. Nice having you in this video. Looking forward to seeing you in my next video. Your assignment for this video, for this lesson, is just copy out these examples we have done and rework it again. If you are having challenges along the way, then you play the video again and then move on. That is your assignment. Then, however challenging the assignment is, drop your comments in the comment section. Looking forward to reading your comments in the video. Thank you very much, friends. Looking forward to seeing you in my next video. Bye.